Alright guys, here we go. Because I need to save my drink for tonight, we're doing a different challenge. This is Physics 2025, but every time I spend longer than 1 minute, I need to get a timer for this, 1 minute per question, I have to beat Deadlocked in Geometry Dash. So 1 minute timer. Okay. So, let's get going. Why can't I see the timer? Okay, huge. Marlon and Karen are riding jet skis on the lake. Marlon jet skis fit in the air horn. Actually, I'm gonna make it a minute and a half. Just because some of the questions won't be impossible in a minute. Stops and down trails directly towards the calculator. Okay, so she hears 343 times 1043 on 343 minus 27.3. This is 343 times 1043 on 343 minus 27.3. 1131.2 hertz. Okay. Huge. Each wave front emitted by the horn on the jet ski is bunched up the one's front of it, since the jet ski is moving some non-zero velocity in the same direction as the wavefront's front, and hence wavelength decreases and frequency increases. Okay, huge. Karen is in a position where the component of the velocity coming directly toward her is unchanged until it goes past, so it's a straight graph, sharp dip, and a straight graph. Only really two distinct frequencies are hit. Aaron is some way to the side. This means that at far values her heard frequency is pretty much what Aaron hears, since the components are the same, but when it gets closer due to her being to the side, she hears a different component, different frequency, since the component of the jet ski's velocity toward her is less than that of Karen. Oh, Aaron. No, Karen. Right? Huge. So Martin's jet ski engine makes a sound. Hang on. Oh yeah. Okay, So 563.6 times 27.3, 1538.28 equals 574 minus 15386.28 divided by 37.4. That equals 411.4. That cannot be correct. That is, the velocity of sound in water is way quicker than that. What? Well, I guess that's what we're going with. Whatever. That's not the speed of sound in water though, but whatever. Called the bridge nut. It's closed standing wave, right? So it's like so that's node. Tension changes velocity since length is constant, each wave length constant moment, but since we changed if changes, if tension increases, decreases, and vice versa. First harmonic is increasing string. Oh, okay, so this means that the first harmonic is half a wavelength, whereas lambda equals 2L, right? That's the first harmonic, yeah. So V equals 147 times 2 times 0.69. Right, and this should be the same, because the tension is left unchanged. Right, so that's the speed of the wave on the string for that and on the U string, because the tension doesn't change and the V doesn't change by this. Play the first harmonic. Okay, which means that 202.86 on 207 equals lambda, which equals 2L. So the new length is 202.86 on 207 times 2, 0.49 meters. Huge. I haven't actually played Deadlocked yet, it's going well. Two strings at the same time, when string 2 is played, increases the note with the frequency. String 1. Have I started the timer? Oh shit, I have. So my beats form. Press into string 1. Beats form 2 sounds play at a slightly different frequency to one another. So they drift in and out, in to frequency, a beat is heard as they drift in and out of phase. Yeah, alright. The beat frequency will get smaller and smaller until the frequencies match and perfectly resonate, and then it will get larger and larger as the frequencies drift apart again. So a fast beat becomes a slow beat, which becomes resonance, which becomes a slow beat, which becomes a fast beat, and then no discernible beat is heard. That makes sense to me. Yeah, I buy that. So it's 1.25 interval D times X on L equals 3 lambda. So lambda equals 1.25 times 10 to the minus 4 times 4.2 times 10 to the minus 2 3.4 times 3. That's 5.147 times 10 to the minus 7, which is 550 minutes. Here's as shown. Well, when the light arrives in phase, whole number of wavelengths apart, then the brightest spot forms since construct interference is here. When the light arrives exactly out of phase, you get the dark spots due to perfect destructive interference. As the but yeah, and then between these 2 points, the intensity varies as the level of interference varies. Good enough to me. This will produce a sharper and clearer interference pattern. The approximate positions don't change, but the maxima are more clearly well defined and can be seen more sharply. range of values for the slip separation of it. Run through a different seven maxima are seen on the screen. Oh, okay. 1, 2, 3. Okay, so we only want 3 orders, which means that oh wait. Oh, this was with the previous question. Oh, good. This is rough. This is really rough. You want like max. Hang on. dx on L. So dx on L. So x is 0.45 on 1.2. That is n times 515. But n is less than or equal. Sorry, n is less than 4. Right, it has to be less than 4. Which means that 515n is less than 515n is less than 2060, which means that d times 0.45 on 1.2 is less than 2060. So d must be less than 2060 times 1.2 divided by 0.45. Wait, no, this doesn't work. What? How can that be true? Oh, I forgot nanometers. No. Wait, there's still time, there's still time. But n is greater than 4. N is less than 4, so n is less than... Yeah, n is less than 2060, which means d times... times 10 to the minus 9. So d must be less than... d times 0.45. Okay, fuck. I'm screwed. Oh, I stopped the time. No, I reckon that's... Damn it. Okay, I'm gonna be deadlocked. Oh, wrong level. Sorry, man. I thought I'd make it through the whole paper without having to do this. I don't know how long this is gonna take. Let's just get through that 10 minutes of video. Oh, God. Probably don't have very riveting commentary for this section of the video, but oh well. Huge. Okay, thank God, thank God, thank God. Okay. I can beat this. So d times this that's got to be less than this. Right? Because if it was greater than that, then a value of 4 for n would be possible. We don't want that. So d would have to be less than That's a rough question, actually. Okay, all good. Let's go with that. And oh wait, same paper. 9, 1, 2, 3, 9, 1, 2, 4. Right. Okay, mechanics. Oh, I'll get us to shut up. Hang on. Go away. Right. Okay. From the center of Saturn. Distance between the center of masses. Oh, okay. So xcom equals m1 x1, but that can just be m1 x1 m2 x2 m1 plus m2. We can just make x1 0. So interesting. So Titan is m2. It's 1.35 times 10 to the 23 times, and the distance away it is 2.9. Oh no, whoops. 1.22 times 10 to the 9 on m1 plus m2. So 5.68 times 10 to the 26 plus 1.35 times 10 to the 23. So 1.35 times 10 to the 23 times 1.22 times 10 to the 9 divided by 5.68 times 10 to the 26 plus 1.35 times 10 to the 23, and that's 2.9 times 10 to the 5 meters. Okay, all goods. So the initial momentum right, well that's 2.45 times 8. It's 19.6, and this one's 3.2 times 15. That's 48. So square root of 19.6 squared plus 48 squared. 51.847. Particles cluster together without losing any mass. So 51.847. Direction of the momentum of the two particles. So it's 51.847 kg meters per second at tan inverse 48 on 19.6 at 67.7, of course it's 67 degrees below horizontal. Relative to the initial, yeah, that's conservation of momentum, right? Wait, it's easy actually. Start together. Yeah, you just do the triangle, right? Pick one orbit of Saturn. FC equals FG mv squared over r gmm r squared. Do we only get one of the masses? Oh no, it's fine. V squared equals gm on r. So 4 pi squared r squared. I'll just write that down on t squared equals gm on r cubed. So t squared equals 4 pi squared r cubed on gm, which equals 4 pi squared times the radius of orbit, which is that, so 1.22 times 10 to the 9 cubed divided by 6.67 times 10 to the minus 11 times the mass of Saturn, which is 5.68 times 10 to the 26. Then I square root that answer, and you get t equals 1375569 seconds. Huge. Oh! Yeah, no, I reckon that's... I reckon we've got to play. No, actually I saved that. I was just in time. That counts, trust. Further man mission might be launched in space stations and the astronauts on the International Space Station. Because they are moving in a circle. There is no reaction force present as all of the centripetal force is exactly equal to the net force, which is gravity. They therefore appear weightless, since they cannot feel a support force from the ground. That's easy. I didn't put the time on that, but it's fine. Steadily accelerates. Just 12 seconds. Omega equals... Oh, wait. The angular acceleration is 12 seconds to make 4 rotations. Right, so it's 4 rotations, that's 2 pi, that's 8 pi radians. Oh, wait a minute, what the fuck? Wait, what am I doing? Equals 0. We have t equals 12 seconds. We have theta equals 8 pi. Of course, WF equals, what's the formula? WF squared equals WI squared plus 2 alpha d, 2 alpha theta. No, it doesn't work. Distance equals average velocity. Oh yeah, so theta equals WI plus WF on 2t. Yeah, okay, that works. So WF equals 2t theta. Yeah, 2t theta. And that's 2 times 12 times 8 pi. No, that doesn't work either. What? What am I doing? Wait, I'm an idiot. I'm actually just like... I'm not even looking at the question properly. I just like lost the timer. What? Hang on, how does that question work? I'm not subbing into a formula. That's a cell. Hang on, so it's 4.19 radians per second. That's, 12 seconds. But what's the formula? WF equals 16 pi divided by 12. Yeah, so 16 pi divided by 12 is 8 pi, so 4 pi, so 1.33 times 2.14, which is 4. Okay, here we go, that's the answer. Oh, what? I'm gonna forget how to do the problem. Thank God. Okay. Okay, so it's actually fine. It's WF, no, it's distance travelled equals average velocity times time. So WF equals this, which is 16 pi on 12, which is 4.19. Okay. Acceleration is 4.19 that's 1.2, so 430 times 4.1. Oh god, I need to get the game to shut up. No, I don't want to quit. I'd like the music to go away. There we go. 430 times 4.19 on 19.2. Okay, so the angular momentum that Jane brings is equal to 52 times 6.39 NVR. So it's 398.736. So the total angular momentum is now 398.736 plus the angular momentum beforehand, which was 430. Oh wait, it's not spinning, right? Stationary roundabout. Oh, okay, so that's alright, which means that 398.736 is equal to I alpha, I omega. Well, I is 430 plus 52 times 1.2 squared times omega. So omega is 398.736 on 430 plus 52 times 1.2 squared. So that's 0.79 radians per second. Huge. By moving inward, she decreases the rotational inertia of the system, thereby increasing its angular velocity since L is constant. Rotational kinetic energy can be expressed as L equals half I omega squared, which is actually equal to saying half L omega. You swap one of the IW's with the L. Since W increased, so too did rotational kinetic energy. Rahari has converted mechanical work to rotational kinetic energy. Or also, I guess, her linear kinetic energy. Her linear kinetic energy is, I suppose, now less if she is closer to the center. But then, of course, omega is bigger, so is that into the same proportion? I'm not too sure, actually. But whatever. Should the maximum displacement of the ball is that? Well, it's going to be amplitude equals 1.2 sine 5.6 degrees. And you got a frequency equals 2 pi on the period. So that's 2 pi on 2 pi square root ln g, which is equal to root g on L, which is equal to square root 9.81 on 1.2, 2.86 radians per second before it's reach a point as shown on the diagram. Will reach a point 3.3 centimeters before its next stationary position. Oh, okay. So that would mean, the total distance, right, is 2 times 0.117. So 0.234 minus 3.3 times 10 to the minus. Well, okay, whatever. It's the displacement x. If this is x, it can be written as 0.117 times cosine omega t, so 2.86 t. And if I want x to be 0.117 minus 3.3 times 10 to the minus 2. I want x to be negative 0.084 because that's 3.3 centimeters away. I want that to be equal to this. And make sure you're in radians. And you go negative 0.084 on 0.117 arc cos of that divided by 2.86. And you get t equals 0.829 seconds. Okay. Now when he twitches his hand at the natural frequency. He twitches his okay. He twitches his hand at some frequency f. If he can match the desired / natural frequency of the pendulum, if it were just a standard pendulum, he will be resonating the system by inputting energy and force exactly when desired. Sort of like how people push a swing and it pushes exactly when you need to. Hence, a large amplitude builds up as energy is inputted faster than it is withdrawn from the system. Huge. Okay, that does that. Electricity next. Okay. The terminal voltage of the battery. Current from the battery is that. The terminal voltage is 12.6 minus I times R, which I presume is the answer we are looking for. Yes. The internal resistance will increase. So, increasing the internal resistance will mean that the voltage drop. But that it lowers the circuit current, right? Wait, there's actually a few things to consider here. Because, like, the current in the circuit will simply be EMF divided by 6 plus R, right? And then that means the terminal voltage is the EMF minus IR. So this is 6 plus R. So that equals the EMF 6 plus R minus R. 6 plus R equals EMF, 6 lots of EMF and 6 plus R. Okay. So as R increases, the terminal voltage decreases. Good. This is capacitance of 90 farads and is fully charged for battery. Oh Jesus! All right. Oh wait, there's no timer. Yeah, that's fine. RC. So 90 farads. Times that, so that's 540 seconds. Does takes 540 seconds for us to be at like 0.37. It's about there, right? And then 0.37 times 0.37 is about 0.13, and that's at 1080 seconds. So 0.13 is really about there. And then times by 0.37 again, that's 0.05, so it's like down here, and that's like 104, so that's like 1620, and so on, that's right, so it's like graph should include the initial current. Oh, is it not just one? Oh, well, I thought it was like a percentage of the total. That's so stupid. Okay, whatever. The initial current, when they close the switch, to a 4-volt battery. So 4.2 divided by 6 is 0.7. Okay. That's the initial current. So times that by 0.37, and you're at 0.2526. So 0.26 after 540 times by 0.37, 0.1 after 1080 times by 0.37, 0.035, 0, yeah, alright. So like that. Imax equals VR, right, and then, I1 equals 0.37 of Imax, so that's I1. Good enough for me. Oh, I ran out of time. Let's try something more interesting. Going so well. 70% on a hard dim account. I don't care what you say. I make the rules around here. Where the graph is the shape you've drawn, the capacitor discharges a current through the circuit, but as it does, the voltage across it drops, so the EMF is less, so the current drops, which means it discharges slower, so exponential decay. Next one, 3 meter. Reservoir compared to well, that's going to be 3C, and that'll be a third C, so B has 9 times the capacitance, so has a time constant 9 times as great, hence takes 9 times as long to charge. Well, B takes times the capacitance, as A. B takes 3 times as long as just 1C, and A takes 3 times shorter than just 1C. Sure. Once I've got the time number, that's fine. The switch is first closed. Well, it'll be 12.6 volts. There'll be no current, or approximately no current. Okay, this is going to do 0.24 seconds. Oh wait, the time constant is ln right? So that's 0.6 on 2.4 plus 0.1. Yeah, it's 0.24 seconds. So the current equals 0.63 of the maximum current, which is 12.6 on 2.4 plus 0.1 equals 0.63 times 12.6 on 2.4 plus 0.1, 3.1752. Size of the induced EMF. So 12.6 minus 0.1 times 3.1752 minus 2.4, lots of this, should equal VL. Minus 2.4 times 3.12, 662 volts, I think. This will just open, explain as more spark is produced, the inductor rapidly discharges its magnetic energy, its current through the circuit. This rapid change in flux through its coils produces a very large back EMF for a brief period of time. Hence we see spark as air ionizes. Good enough for me. Still not always see that. She knows that if she places it like a capacitor, she can store it. Capacitor is fully charged with a 12.6 volt battery. What's the energy total? Is half L I squared, right? Half L I squared for the inductor. So that's what, half times the inductance, which is 0.6 times I squared. Well, I squared is 12.6 on 2.5 squared. So that's 7.62 joules, and that equals half CV squared. So C equals 2 times 7.62 on 12.6 squared. 2 times 7.62 on 12.6 squared. That's 0.096 farad. Okay. Lead it to a variable frequency 0 for ideal inductor and resistor. Okay. Reactance of the inductor is that. So XL equals to mega L, right? So it's 2 pi times 25 times 0.6. Yeah, so it's 2 pi times 25 times 0.6, which is 30 pi, which is 94.2 ohms. reactance. By doing so, the reactance of the inductor is increased. This means that the impedance increases. This means that the circuit current decreases. This means that the RMS voltage over resistor decreases. Good. I just set the voltage across. VR is maximized when I is maximized. At this frequency, I is maximized, so VR is maximum. This is the resonant frequency and occurs if and only if XL and XC are equivalent, hence making the net reactance 0. Thus, there only exists the one frequency where this is true. Presumably that was for the previous questions, that's fine. And the supply frequency is 16 Hertz. Okay. VL. Well, VR is going to be, if you put a voltage thing, this is sort of in the skull physics, you put a voltage thing across the whole thing, you'd have to consider the combination of these two, but I'm not going to bother. 70.4 is VR. And we got VC and then like VS or something like this, right? Oh, actually, it's further reduced. The frequency's reduced, then XL gets smaller, right? So VL should be smaller. Okay. VL. So really this is VS down here. Okay. VS equal, well, the impedance is the square root XL minus XC squared plus R squared. So XL is omega L, so that's 2 pi times F, so 16 times 0.6. Okay. Minus 1 on omega C, so 2 pi times 16 times the capacitance, which is 1.2 times 10 to the minus 4. I want to square all that and add on the resistance, which is 70.4 squared. Yeah, what's wrong with this? Math error. Why is it telling me there's a math error? Oh, wait. Okay. So the impedance, and then the square root of that. So that's 73.93 ohms. The current of the circuit is the voltage, which is 9 divided by this. So it's 0.1217. Right, there we go. Huge. Did I do it in time? Why did it stop there? I don't know. Well, that's exactly an hour. I think that will do it. Goodbye, live stream tonight. With Speedy Memes. It's on Speedy Memes' channel, not on my channel. We're doing Skull Calc Race against suboptimal players. It's going to be glorious. So yeah. Right, I'm going to go listen to some music. Goodbye.